Good morning, everyone, and welcome to this morning's Tech Talk webinar. Today, we will be going over design and assembly services. So thank you all for hopping on this morning. Really appreciate all of you jumping in here. We've got about 30 minutes or so of content that we'll go through. And just want to touch on some of the design and assembly work that we do here at SwageLock Northwest, and go over some examples of how this has been applied and helps companies just like yours. For those of you that don't know me, my name is Matt Hazenor. I'm a field engineer here at SwageLock Northwest. SwageLock Northwest covers Oregon, Washington, Northern Idaho, and Alaska. And as field engineers, we're a global team that gets involved with fluid system challenges, new construction, existing installations, trying to troubleshoot things. So we take that knowledge and things that we've learned and try and share them here with you guys in the form of these webinars. So we really appreciate you guys hopping on. Let's see here. We're having, looks like Adam is having a little difficulty signing on. Bear with us here. All right. We'll just, we'll push on here. Adam was hoping to join us, but it seems like we've got some technical difficulties preventing that from happening. So if he hops on, we'll let him introduce himself. So yeah, we'll talk a little bit about some of the current pressures that companies are facing today, and how SwageLock's design and assembly services can help alleviate some of that, and what we've done to try and adapt to those changing pressures, figuratively and literally, actually, to address that. And then, like I said, we'll go through an example of a project that we worked on not too long ago, to kind of paint the picture of how this process works and what some of the type of work we do here. Bit of housekeeping here. We do have a chat function on the right side of your screen. So feel free throughout the presentation, if you think of questions, throw those up there. We will address those throughout, or can address that at the end of the presentation. We will also throw up a poll question there, so that let's go ahead and do that. We'll kick it off with a poll. So what is the most significant challenge facing your company today? So you should see that poll question pop up. Feel free to throw in an answer there.
Hey, sorry about that, guys.
Hey, we got him. Awesome. Glad to have you, Adam. Real quick, Adam, while they're answering this question, I don't know if you want to introduce yourself.
Yeah, for those of you that don't know me, my name's Adam Ganoom. I'm also a regional field engineer based out of Portland. So been with SwageLock about 6 years, 4 of those with our factory back in Cleveland, and then came out to the West Coast to join the team here. But one thing I wanted to add with this poll question, we saw a kind of neat statistic that 71% of companies right now hiring are having trouble hiring skilled employees. So I think that pretty neatly ties into some of the pressures that people are experiencing, like the doing more with less and knowledge loss that we all are experiencing, especially as some of the generation turns over. So if we go on to talk about some of those customer pressures, like we mentioned, knowledge loss, safety and efficiency, and just doing more with restricted resources, SwageLock has worked very hard to try to position ourselves to help alleviate those pressures and work with you as not only a component supplier, but also to help provide some of those solutions for you, or things like training and advisory services as well. So something I just wanted to point out, this is a new tool that we're using, and it's actually augmented reality glasses. So what this allows is one person on your site, especially during these COVID times, cutting down the people that are actually on site, but we're able to tie into a team of subject matter experts around the world with SwageLock to help debrief and solve any of those problems that you may encounter on site. So if we think about SwageLock services in general, we talk about it, I like to think of it kind of as 3 different pillars. We have that design and assembly that we'll be talking about a little more in depth coming up here in a minute. But we also have on-site services, so like hose evaluation services, and then just field advisory services as well to help you troubleshoot and maybe improve the efficiency of your system. And then we have a great team of people within SwageLock and people that we collaborate with from different consulting companies to provide training for specific pieces of that fluid system technology. So today we're going to be talking about the design and assembly services, and that ranges anywhere from, really simple high volume assemblies. So something like a tube bend, maybe with a fitting welded on. But also we have the ability and the resources on site to build some very complex assemblies. And fabrication services, we also have a suite of pre-engineered systems such as fluid headers and gas distribution systems, along with grab sampling and things like that. But we're also able to kit things, if it's an install or replacement parts, we're able to provide those kitting services, and then design and layout services, and also automation of some of the fluid system components as well. So assembly services specifically, like I said, simple or complex, and there's a couple of examples of PNIDs that we may start with, and what we'll do is we'll work from that PNID or the existing system, and we're able to produce a CAD layout of it and then move on to construction. So this is anything from enclosures, skids, tube bending, panels, things like that. And we also are certified in ASME Section 9 welding, and more recently we were able to get cleared for some NAVC requirements as well for welding. Like I mentioned before, the pre-engineered solutions. So these are anything from sampling systems, mechanical seal support systems, valve automation, so automated ball valves that we can tie into our control systems. But also locally, we have a hose cell at our distributorship where we're able to manufacture custom hoses in all sorts of configurations. So, really, we're able to provide a great suite of systems for those common applications that we run into in the field. So with that, I'll pass it back over to you, Matt, to go through the case study.
Thanks, Adam. Yes, we want to run through an example here, start to finish of a project that we worked on recently that pertains to the design and assembly services. So what we were looking at, and this was an example here, we've known this engineer for some time, and every time we would meet, we would go through what projects we're working on, what projects is this engineer working on, and there were these projects that would be brought up every time, but when we asked about them, the project folder got pulled out from underneath a stack of about 10 to 12 other projects, and it just went further and further down the list. And so it was like, he came to us and said, hey, is this something maybe you guys could help me out with rather than taking this on and using our engineering resources? Is this something you guys can do? We said, yeah, let's take a look at it. So what we were looking at with this one was that they wanted to take a new measurement on their plant water system. And they wanted to specifically look at impurity levels. And so we started out, let's capture some initial information here. So our process fluid is water, and there could be some trace hydrocarbons in there. And one of the biggest challenges with this is that we're running at atmospheric pressure. So there's pretty much no pressure in the system where we wanted to take that measurement. So we had to come up with a way to create a motive force to take that sample. We're not just able to dip a jar into our process and take that sample. So we needed to figure out a way to transport the fluid to get it into our glass bottle, which in this case is what our capture method was. And then that would be taken to their lab on site for analysis. So kind of get an idea here of the process conditions, what we're looking at, and then go from there. So next we did a field walk. So we do these with a lot of our systems, and these don't always look the same. In this case, it's getting your PPE on, going out into the plant, and look at any existing constraints with where we're going to be installing the system. So in this case, we're looking at a hazardous area classification. We did have some physical size constraints. Where are we fitting this in to what the existing, in this case, existing piping structure. So we want to kind of scope all of that out and get an idea of what this system's needs to look like and what's limiting us. There were some, this is going to be installed outside, so there's environmental concerns there. How do we account for that? Longevity of the system, doing any maintenance, accessing the system. And then we want to look at existing plumbing. So we said, okay, where are we pulling from? Where are we disposing the sample safely and doing? And then if there's any other utilities or auxiliaries that we need to pull from, be it electrical, purge gas, plant utility water, things like that, we're going to scope that out in this initial piece. Now, this was a field walk. I do want to mention with other projects, sometimes it could be, hey, we meet like this or on Teams, pull up some pictures, pull up a CAD model and kind of look at, okay, how are we going to move forward with this project? What do we need to change? Get an idea of what we're working on. So Adam mentioned that virtual or augmented reality headset where I can be sitting here, he can be out in the plant. We can kind of both be looking at the same thing and talking. So some pretty cool technology that we've been able to use for projects like this. So at that point, we start working on a concept. And so in this case, given that we were taking a sample, we said, okay, well, let's start with a standard grab sample panel design that we have. So we started with the standard design, but then we started modifying it based on plant standard as well as what we wanted to do. So here we need to come up with a motive force. So we used an eductor or a jet pump and their utility water to create that motive force to drive flow through the panel. And so we sketched this out, here basically by hand to come up with that. And the engineer said, hey, I also want to measure pH with the panel. And I do want to have a flow switch as well. So that way we know if there's flow through the system. So we then updated the PNID, said, okay, well, let's throw in that pH probe as well as a flow switch. And then all of the valving that needs to go with that for proper isolation, filtration, dropping the pressure of the incoming utility water, as well as doing some line sizing and running pressure drop calculations to make sure that, if we need to run 100 feet of half-inch tubing, we're going to be able to do that with the pressure drop or the pressure that we have with that eductor. So once we get kind of come to an agreement on a PNID, we'll create a more formal version of that just for approval purposes. So we'll sketch that out in Visio in this case to give, a solid idea of what this system is going to look like. And then once we have that schematic finalized, our CAD team will get to working their magic in SolidWorks to give us a 3D model of the system. And we like to come up with a 3D model for every system that we build. And the reason we do this is just to give us, one, it gives us a nice clean finish on what we're building. We can get an idea of what it's going to look like so we can, update the size, make it maybe more ergonomic to use, easier to access parts for maintenance. It just leaves fewer questions downstream when we start to put this thing together and get it on site. We want you guys or the customers to know exactly what it's going to look like, how it's going to be installed. Just helps smooth the process out downstream. So we'll go back. We went back and forth on what it needed to look like. So this panel, the standard design that I mentioned would be about a third the size of what you're seeing here. So with the additional valving and eductor system, we had to increase the size of the panel. Then based on some physical limitations, we needed to shrink that down, add some extra supports here with the pipe stands in order to fit this system into its location of where it was going to go. Once we had a general idea of, came to an agreement on the 3D layout of the system, we're going to create a 2D drawing with bill of materials. And we really do this just to make sure that we know exactly what components are going into it. We can review it to make sure we're meeting pressure requirements, temperature requirements, as pertains to ASME B31. So we got to look at that. And then we can lay out any third-party products. So one of the nice things about these design and assembly services is we're not just using Swagelok components. So if you have, in this case, pH probe or a flow switch, we're able to bring in those third-party products and implement them in our shop into the system. So it doesn't have to be just Swagelok components. So we'll get that onto a 2D drawing and get that reviewed both internally and by the customer, and go back and forth if there are any, part number changes, or maybe seal material needs to change, or a filter element size. We'll go back and forth, get a final approval, and then it will moved over to sourcing and procurement. So we have a team of sourcing and procurement specialists, and they will get to work on bringing in all the material needed. And the great thing about this is, the customer on this project sent us a single purchase order for one part number, and that was it. That's all that that's the only purchase request that they had to make on their end. It's the only purchase order that they had to send us. And so our team will get to work bringing in all that material, handling the supply chain of it. And, we sometimes have upwards of 25 POs for our team, and that's going to multiple vendors. And we do have a list of approved suppliers that we use. So we try to vet all of our suppliers to the same quality standards that we hold for ourselves. So we take pride in manufacturing and assembling high quality systems. So we want to make sure that everything that goes into that meets the same quality standards. Once all of the material arrived on site, we can then start assembling the panel itself. So you can now see this was the same system that we had there on the drawing and on SolidWorks, and that PNID. So you can kind of see it throughout the process. So our team, we've got a trained and certified assembly team that has experience with panels and enclosures. They're expert tube benders. They work their magic out there. And our shop floor, they take pride in how clean it is. It's definitely not your typical manufacturing site. Much like Swagelok's manufacturing area, we try and keep a high cleanliness standard on just the area itself, because I think that then trickles down into the work that's done and making sure that the systems are clean. Once the assembly is completed, we then do a pressure test. So we have different pressure testing capabilities that we can do a lot of bubble leak testing, pressure decay testing, and in this case, I think we did a helium leak test on this. And we'll do function testing as well as needed. So this one, we want to make sure, hey, before we get it on site and ship it to the customer, we want to make sure that we do a function test. It works as designed, and there's no updates that are needed before shipping that out. So then we'll package it up and ship it out. So we do quite a few custom crates, barrier bags to protect from the environment if it's depending on how far it's going. But really here we want to, we want to make sure that this system that we've spent all this time designing and building, that it gets shipped without any damage and arrives on site ready to go. We'll do, caps on open connections, tie-in points, things like that, just to make sure that there's nothing crawling in there while in transit. And then once it's on site, for this system, not for all of them, but for quite a few systems, we try and provide on-site support during that installation and commissioning of the system. And really this is to answer any questions that might come up during installation, being it that our team was involved in the design and build. But really we often end up coordinating with operations, engineering, and contractors to make sure that the installation and commissioning piece goes smoothly. And with that, what we find a lot of times when we go out and review systems is that the system itself or the subsystem was often designed and built to high quality standards. And then the installation is where something gets missed. Inlet and outlet are swapped, or it just doesn't, the tying in of the system, there's a few steps that are skipped. So that's why we try and make sure that being on site, we help to ensure that that system's properly installed and the process is followed as designed. So Adam, I'll pass it over to you to go through some of the takeaways here.
Yeah, thanks for running through that, Matt. I think it's really nice to see from kind of conception to installation and the pieces that go into it. But essentially, what ties it up nicely is there's going to be significant time savings. So not only in engineering and the sourcing and procurement piece of it, but also, down the line, having a hand in the origination of the system. It's much easier for us to help troubleshoot issues within a system based on our experience with it. So, utilizing those resources, and everyone likes cost savings and being able to do more with less, like we talked about. But another thing I wanted to highlight is that the Swagelok limited lifetime warranty extends to the entire system that we provide. So, it's just a little pat on the back for you. When you're installing this, you can feel good that not only is it designed and functioning properly, but we're there to support you if there is any issues. Again, with downstream support, we're able to be there and come help you tie it in and all of that.
Yeah, I think with this project that I mentioned, it was, the engineer, the value that they bring to their company is not designing some of these smaller systems. It's dealing with the much larger process control, process measurement. And so being able to offload some of the smaller projects that he was working on, it really allowed him to focus on the value add for what he is an expert at, and really get some of those other projects done that he needed to.
Yeah, absolutely. And with that, we'd like to wrap up. There's going to be a couple links that'll pop up for you. One is just a little more on the success stories of the design and assembly services that we provide. That is pretty interesting to dig in. They talk about the cost savings and things involved with that. And then we'll also have some resources just kind of what we went over today. But if you want to do some more digging or pass it on to fellow coworkers, it's a good resource for kind of covering what we covered today as well. With that, any questions, we'd be more than happy to answer. If you think of something later, or you have maybe more application specific questions, our information is on the screen, and you can feel free to contact us, and we can help you work through any issues or questions you may have. So I'll give it a few seconds, see if we have any questions coming in. But really appreciate everyone joining us as well, and hopefully you got something out of it. So, Matt, we have a question from Peter. Do you do prefabricated systems in high purity plastics, valve manifold boxes?
Yeah, that's a good question. So we've done, I know we've had some experience with these. And I know we've done some of the plastic stuff. Reach out to us. I don't have specific examples because I know Swagelok Factory has done some of that. In the valve manifold box, I know we've helped with those projects. We have quite a few products that go into that. But Peter, reach out to us to see. We do have some folks that have done gas boxes and gas sticks with that clean room assembly. So feel free to reach out to us and we can talk more on what you're working with.
We got another question from Ivan. Do you produce O&M manuals?
Nice. So I'm assuming this is operation and maintenance manuals. So we do for some systems, we have manuals that we'll put together. It kind of depends on the requirements from the customer. So we have, in certain situations, put that together if it's something where it is difficult to operate or maintain. A lot of times most of the maintenance is just maintaining the products themselves. But for certain systems, we do provide those operating and maintenance manuals. Good.
Sample panels, or all of our grab sample panels will have the instructions posted on there, as well as a step-by-step on how to operate it. But that's always something we can work with the customer on if it's a requirement as well. So we got a question from Kelly. Lead time on estimates. So I'm not exactly sure if you're asking if we provide a lead time on our estimates, but when we put together these quotes, we work with our shop floor and the planning department to make sure that we're capturing all the labor required to go into them. And then additionally, when we have quotes from outside suppliers and our factory, we do have lead time. So when you receive a quote, it will have a lead time on there, and that lead time is from the receival of a PO to delivery. So we do work quite hard to reduce lead time. Try to use most off-the-shelf parts, things like that. But depending on what it is, we'll work hard to get that reduced to a manageable lead time. So with that, I think we'll wrap up. I really appreciate everyone joining us. And again, feel free to reach out directly, and we'll be happy to walk you through.
Thanks, everybody. Take care.
Thank you.